Hello viewers, welcome back to Lobby Premium Consult. In today's video, we are going to look at a sample frequency distribution question from a particular company. So I read, a sample of a monthly gold amount invested in Waste Gold Company by 8 employees is depicted in the table below. So we have the amount invested and then we have the number of employees that take this investment. So the examiner told us to use two decimal places in this particular case. So I estimate the mean amount of the gold invested. I calculate the mean deviation for the distribution and interpret. I estimate the sample standard deviation. And IV find the coefficient of variation for the distribution. All these go for what? 15 marks. So we are going to have our table for amount. We're going to have our table for what? The number of employees. So the amount is going to be the X values and the number of employees is going to be the frequency in this particular case. So let's take note of that. So the first requirement here is you have to estimate the mean amount of gold invested. And to find the mean amount of any frequency distribution or any stat related question, to find the mean, you say mean X bar is equal to summation F of X over what? Summation F, where it is in the form of what? A frequency distribution. But it is a form of a raw data that we say that X bar is going to give us summation of what? The X values and then divided by what? N. So that's what we're going to talk about in this part. So we're going to have a column for the amount invested and a column for the frequency. That's the number of employees in this particular case. So that is a column for the amount invested and then the number of frequencies in this particular case. So these are the frequencies that we have and then the amount invested. Okay, so because we are asked to find or estimate the mean amount of a gold invested, for which we know in this particular case is going to be mean of X, or X bar is going to give us summation F of X over summation F. We need to also have a column for summation F of X, right, so that we can easily estimate the mean amount in this particular case. We are going to also have a column called F of X, a column called F of X. So that's going to be a column F of X. So that means that we are multiplying what? The amount invested by the total frequency in that row form. So you take 40 multiplied by 10, 50 multiplied by 12, 60 multiplied by 20 in that particular order. I hope that is fine. So that's what we're going to do. So when we take 40 by 10, you'll be getting what? 400. Okay. And then the second one, we're getting what? 600. That's 50 by 12. And then 60 by 20, you'll be getting 1200. Then 70 by 15, you'll be getting what? 1050. And then the next one, you'll be getting 2400. And 90 by 8, you'll be getting 720. And you're getting here to be 200. And lastly, you'll be getting what? 330. Alright, so once you have gotten F of X, you find the total for F of X. Likewise, we're going to find the total for what? The frequency in this particular case. So when you add all the frequency, that should give you what? Summation F. And when you also add all the F of X, that should give you what? Summation F of X. Okay, so let's see the total frequency. So the total frequency, with my calculation, I had a total frequency of what? 100. And then that of F of X, I arrive at 6,900. So that should give us what? The F of X and then the frequency in this particular case. So once you have gotten that, the I part of this question is saying that we need to estimate what? The mean amount of gold invested. So how do you estimate that? So to find the mean, we know mean per formula X bar is giving us what? Summation F of X, right, all over summation F. But we know that summation f of s in this particular case was what? 6,900, and then divided by our summation f, which is what? 100. So therefore we can say that the mean amount is going to give us what? 69 in that particular case. So this becomes our mean what? Amount. It becomes our mean amount of gold invested. And once you do this, fetch your marks of what? Three marks in that particular case, and then you're good to go. So that is the I part that we are talking about. The next requirement is to calculate the mean deviation for the distribution and interpret. How do you calculate the mean distribution? It's always best for you to know the formula, and that will help you to know the number of what columns you're going to produce so that you can easily calculate in that particular case. So to find the mean deviation, call it as MD, mean deviation, for this particular data, it is going to be our summation F multiplying the absolute deviation of the figures, which is x minus x bar, alright, and then divided by the total number, which is what? N. In this particular case, it is what? Summation F. So we can have that as well here as summation F. So this is how you calculate your mean deviation in this particular case. Summation F, that's frequency multiplied by the absolute deviation of what? The amount, and then that of the mean, all divided by the total frequency in this particular case. So this is how we calculate for the mean deviation in this particular case. So in that way around, we need to have a column for what? A column for the deviation, which is x minus x bar, right? And also need to have a column for the frequency multiplying the deviations. So that is the next two columns we need to produce in order for us to calculate for the mean deviation in this particular case. So that's what we are actually talking about here. I here. Alright, so let's go back to our table and continue with it. So we know that we need to have a column for what? The deviation. Call it as what? D, deviation. So here our deviation should be equal to our x minus what? Our x bar. But we know x bar in this particular was what? 69 that we have calculated already. 69. That's right. So that's what we're going to do here. So once we know x 69, you can substitute it here as what? 69. So it is x minus 69. Alright. So for the first what? Amount, it is 40. When you deviate from 69, you should be getting what? Negative 29 as your first deviation, right? Then when you also deviate 50 or 69 from 50, you're getting what? Negative what? 19. Alright. So let's move on. Then we come to 60, you'll be getting what? Negative 9. And we come to that of 70, you'll be getting what? Positive 1. Alright. And then 80, getting positive what? 11. And then that of what? 90, you'll be getting 21. That of 100, you'll be getting what? 31. And lastly, that of 110, you'll be getting what? 41. So this is what we call a deviation. But note, once you're getting your values for the deviation, we don't sum them up, right? You only sum them up where you find the absolute values of what? The deviation. That's why in our formula, you saw that for us to calculate what the mean deviation, it is what? The absolute value of what? X minus x bar over the summation F, right? So the absolute bars here means that if I have, let's say, A with the absolute what? Bar, it should fetch me the same thing as what? A. But if I have negative A and I place in the absolute what? Symbol, it should fetch me what? Positive what? A. So the goal here is that if it is negative, when you find the absolute values of those values, you should be able to what? Get positive. But if it is positive, it remains what? Positive in that particular case. So that is how we find the absolute value for any particular what? Data. Alright, so we are going to find the absolute values of the deviation, and that's going to be equal to the absolute of what? X minus what? The x bar. Alright, so we find the absolute values of, so it's just a matter of what? picking the deviation, then find the absolute value. So absolute value of what? Negative 29 should be positive what? 29. 19 should be positive 19. 9 should be what? 9. Yeah, it's a matter of copy and paste, right? 1 should be what? Positive 1. It won't change. 11 should be positive 11. Shouldn't change. Then 21 should also be what? 21. Then here should be 31. And here should be what? 41. And then you are good to go in that particular case. But per our mean deviation, we said it is what? Summation f multiplying the absolute values divided by summation f. So we are left with another column for the f multiplying what? The deviation. So we're going to have another column called f multiplying frequency multiplying what? The deviation, the absolute values of the deviation, right? All right. So here too is a matter of what? Multiplying what? The frequency by the absolute values, multiplying the frequency by the absolute what? Values. Okay, so here 10 multiplying 29 in that order. So I'm filling it. So we're going to get here to be what? 290. Then you come back to here to be 228. Here is going to give me the next row is going to give me what? 180. The next row is going to fetch me what? 15. Then I'll move to 330. Then 168. Then I have here to be 62. And then lastly, I have here to be what? 1, 2, 3. Alright. So once we get this, now we need to find the total. And this total is going to give us what? Summation f of what? The absolute values, right? So this is what we are looking out for. So per my calculation, I had a total of 1,396. 1,396 as the total summation of f multiplying the absolute values, right? So once you have gotten these values down, then we can go back to our requirement II. We are asked to estimate or calculate what? The mean deviation for the distribution and interpret them. So straight up we can say that the summation f multiplying x minus x bar, in this particular we had what? 1390, that's 1,396, and then divided by the total frequency in this particular case was what? 100. It is 100. Okay, so therefore we can say that our mean deviation is going to give us what? 13.96. 13.96. And the question told us to interpret. So the mean deviation, which is 13.96, this means that the employees' amount invested differ from the mean amount invested of 69 by what? That of the mean amount here. We know the mean amount is what? 13.96, and we know the mean deviation is what? 13.96, and the mean amount to what? 69. So for us to interpret this with respect to the mean, we will say that this means that the employees' amount invested, right, which is on the x values, right, differ from the mean amount, which is what? 69, all right, invested by that of what? 13.96 as the deviation in this particular case. I hope that is fine. So that's what we try to interpret, that in terms of differences with regards to the mean amount, the difference exists by 13.96. So that is the interpretation behind what? The mean what? Deviation, right? So that is that with that. And then the next requirement here is we are asked to estimate what? The sample standard deviation. We are asked to estimate the sample standard deviation. And how do you estimate the sample standard deviation? We know to estimate the sample standard deviation, XD for sample standard deviation is going to give us the square root of our summation F, right, multiplying x minus x bar all squared, and then divided by summation F minus what? 1. Because it is what? A sample, you subtract 1 from the total what? Frequency. So this is how we calculate for the sample what deviation, right? Sample standard deviation. Is that okay? So once you get in this variable, it means that we need to have a column for frequency, of which we have a column for what x minus x bar, for which we have, but we don't have a column for what x minus x bar squared. We don't have that one, right? So we have a column for already for summation f, so that one is okay. So you're going to work a column for x minus x bar or what squared. Is that okay? So that's why we are focusing in this particular case. So let's go to produce a column for x minus x bar all squared and a column for f into bracket x minus s bar all squared. So let's go back to our table. So getting back to our table, we are going to have a column for x minus what x bar all what squared. So here you can clearly infer from the deviation. Because the deviation we have x minus what x what bar, right? So that's right from what here. Is that okay? So here is a matter of what taking the square of what individual what deviation, right? So when I square negative 29, I should be able to get a value. When I square negative 19, I should be able to get what a value. That's what we are talking about here in this particular case. Okay, so the square of what 29 should be able to generate or produce a result of what 841. Okay, then it follows suit. The square of 19, negative 19 should produce 361. And move on and on in that particular case. Negative 9 should fetch me 81. 1 should be 1, right? 11 should produce 121. Then 31 should fetch me what 441. And then that of what 21 rather, and 31 should be able to generate 961. And then lastly 41, I should be able to get 1681. Once you get these values also down, the next step is to have a column for f into bracket x minus x bar all squared, right? So here is a matter of what multiplying the frequency by the various what x minus x bar all squared, right? So when I take 10, I'll multiply by what 800 and what 41. When I take 12, I'll do same in that. So that's what we are actually going through in this particular case to get a column for f into bracket x minus x bar. I hope that is clear. So let's take note of that. So this then becomes the values for the column f into bracket x minus x bar all squared, right? So you have 841, 4332, 1620, 15, 3630, 3528, 1922, and then 5043. So in all, when you sum them up, you should get able to get a total of 28,500. Should be able to get a total of 28,500. So once you have the total of 28,500, that's going to be the summation for that particular case, right? So once we have 28,500, we can easily bring it here by our formula. So here, therefore, we can say that our standard deviation per our formula is going to give us square root of. So here, the whole of summation f into bracket x minus x bar all squared is going to be substituted with 28,500 and then divided by our frequency of what 100 minus, because it's a sample, you subtract 1 from it, right? So once we get this, therefore we can say that standard deviation for a sample is going to give us, so that's going to give us a figure of 16.97, because the examiner told us to actually work in 2 decimal places. That's why I should have converted to what two decimal place. So it tells us that it should be in two what decimal place, 2 dB, and we are good to what go. Right? So that is the standard deviation for a sample what amount of what data, or sample data in that particular case. So that is the III. So let's move on to the last question, which is what IV. For IV, we are asked to find the coefficient of variation for the distribution. Coefficient of variation, CV, is equal to our standard deviation, which is what X in this particular case, right, for the sample, and then divided by the mean amount, okay, all multiplying what 100%. We want to know the proportion of what variations actually that exists between the standard deviation and that of what the mean amount for this sample what data. Okay, so coefficient of variation is going to give us, so we know per our question the standard deviation was what 16.97, so that's going to give us 16.97, and then divided by the mean value or mean amount to be what 69 from option I, which is what 69, right? And then multiply by what 100, and then multiply by what 100, and then multiply by 100. So therefore, with your calculator, you should be able to arrive at what we are working in two decimal places. That's going to be 24.59%. We tell us that it should be what in two decimal places, and this is how we find the coefficient of variation for a particular set of data, standard deviation divided by the mean amount. So this is where we bring an end to our question 2 for this sample data. So if the video was really helpful to you, please go ahead to smash the like button, subscribe to the channel, and share with your friends. So I will see you in the next video, where I bring to you video on correlation and regression, a full set of questions, so that you can easily understand it and to pass your exams. So I'll see you for now. Bye bye.